Hi guys, so welcome to one more interesting session on prime numbers and composite numbers. Let's try to understand what is a prime number. Right now, a prime number is a natural number which is greater than 1 and it is also divisible by 1 and itself. Right? In other words, it has exactly two positive factors. So whenever I talk about a prime number, it can be written in the form of only 1 into p. For example, when I talk about 2, 2 can be written as 1 into 2. Let's say I talk about 13. 13 can only be written as 1 into 13. So these are going to be my prime numbers. For example, if I take 6, 6 can be written as 1 into 6. It can also be written as 2 into 3. If it is written in any other manner except 1 in itself, then it no more remains a prime number. Right? A natural number other than 1 that cannot be written as a product of two integers, neither of which is equal to 1, is called a prime number. Right now, before we move forward, my simple exercise to you would be is pause this video and I want you to write down all the prime numbers from 1 to 100. It's very important for us to identify all the prime numbers from 1 to 100, right? So I hope you have written the numbers. Now let us note down the prime numbers from 1 to 100. So it's very important for us to identify them. So you have 2, 3, 5, then you have 7, 11. Then we have 13, then we have 17, we have 19, we have 23, we have 29, which is a prime number. Then we have 31, 37, we have 41, we have 43, and then we have 47. So these are my 15 prime numbers from 1 to 50. Clear now, greater than 50. 51 is not a prime number because it is multiple of 3. So therefore, I go with 53 is a prime number. 57 is also a multiple of 3. 59 is a prime number. 61, 67, 71. Then we have 73. We have 79. 81 is not a prime number. It's a multiple of 9. 87 is also, 83 is a prime number. 87 is a prime number which is divisible by 3. Similarly, 91 is a dangerous prime number that generally students write. 91 is 7 into 13. So this is also not a prime number, right? So 89 is a prime number. And in the 90s category, we have only 97, which is a prime number. So we have 10 prime numbers from 51 to 100. In short, we have a total of 25 prime numbers from 1 to 100. Right. So I repeat, commonly committed mistakes are 51 multiple of 3 into 17 is 51. 57 is 3 into 19. 87 is 3 into 29. Clear? And 91 is a dangerous prime number. We need to buy hard this. That 91 is 7 into 13. Now, these all are not prime numbers, right? Now, what are the different things that we need to remember with respect to a prime number? Now, one is the only number which is neither prime nor composite. And that's why in the first definition, we saw prime number should be greater than 1, right? Now, 2 is the smallest prime number we know, and 2 is the only even prime number. No other even number is a prime number because they are also multiples of 2, right? So, 2 is the only even prime number. Similarly, there are 15 prime numbers from 1 to 50, and there are 25 prime numbers from 1 to 100. And if you want, you can buy hard this also. There are 168 prime numbers from 1 to 1000. Right now, if I go ahead, now this is also a very important point to remember. Now, what did we write here? If you observe, we wrote 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. We have 31, 37, 41, 47, sorry, 43, 47, 53, 59, 61, 67, 71. 73, 79. Okay. And then we have 83, we have 89, and then we have 97. Now, if you observe, all the prime numbers greater than 3, okay, all these numbers greater than 3 are in the form of 6k plus 1 or 6k minus 1. Now, 5 is 6 into 1 plus 1, 7 is 6 into 1 minus 1, 11 is 6 into 2 minus 1, 13 is 6 into 2 plus 1, 31 is 6 into 5 plus 1, and so on and so on and so on, right? So therefore, if it is a prime number greater than 3, it should always be in the form of 6k plus or minus 1. However, the converse is not always true, which means if I have a random number in the form of 6k plus or minus 1 may not be a prime number, may or may not be a prime number. So if the question says x is a prime number greater than 3, then we apply this logic. And if the question is just saying x is a random number, then we cannot apply this logic. There's a different rule to identify a number is a prime number or not. Right. So in short, if you ask me, how do I classify my numbers? My numbers can be classified, or let me just take you to the next slide. Now, what's a composite? Okay, just 1 second. Yeah. So we have 2 is the only even prime number, right? Then 3 is a prime number, and then all the prime numbers can be written in the form of 6k plus 1 or 6k minus 1. This can be one more classification of prime number. So first classification is 1 into p should be the only factorized form. Second point to remember is 2, 3, 6k plus 1 and 6k minus 1. If the question says the number is a prime number, these two things start coming into picture. So we'll use these two logics to attack the questions whenever the question is saying the number is a prime number. Now let's move to how to check whether a number is a prime number or not. Suppose I want to know, is 117 a prime number? So first I take the nearest square root. So approximate square root of 117 is 121 is 11, right? So approximate square root is 11. Now I write all the prime numbers till 11. That is 2, 3, 5, 7 and 11. Now I start dividing 117 by 2. Is 117 exactly divisible by 2? No. Is 117 exactly divisible by 3? Yes. 117 is not exactly divisible by 5, 117 is not divisible by 7, and 117 is not divisible by 11. Now, since it is divisible by 3, which means this number is not a prime number. Let's take one more example. Suppose I take square root of 101. Now, approximate square root of 101 is 10. So, all the prime numbers till 10 are 2, 3, 5, and 7. So 101 is not divisible by 2, neither divisible by 3, not divisible by 5, not divisible by 7. So yes, this number is a prime number. So we take the square root of the number and we start dividing by all the prime numbers less than the square root. Right. If it is divisible by any one of the prime divisors, it is not a prime number. The number should not be divisible by any of the numbers less than or equal to square root of n. Right. Now let's take a simple example to, apply this. The number of employees in so and so company is a prime number and it is less than 300. Right. The ratio of the number of employees who are graduates and above to that who are not. And that means we are dividing into two categories, above graduates and who are not graduates, or so and so. Which of the following can be a possible value? Now, if ratio is given, I take 101x and I take 88x. So graduates, so greater than or equal to graduates and less than graduates will be my total number of employees. So my total number of employees here is going to be 189x. Now, first things first, since the value of total number of employees is less than 300, 189 into 2 is greater than 300. Therefore, the value of x is equal to 1. And according to this option, 189 should be the total number of employees of this company. But we have one more condition that this should be a prime number. Right now, it's very clearly evident that 189 is divisible by 3. 3 into 63 is 189. Since I'm writing this in any other form except 1 and into prime number, this is not a prime number. Now, let's try to understand is 187x, 101x, sorry, 100x plus 87x, which means 187x, or the value of x should be equal to 1 because 187 into 2 is greater than 300. Now, is 187 a prime number? Now, let's apply the same logic. Let's take approximate square root. Now, 14 square is 196. Clear? So, let me write all the prime numbers 2, 3, 5, 7, 11, and 13. Mind you, for this number to be a prime number, it should not be divisible by any of these numbers. So, let's start dividing. Is 187 divisible by 2? No. Is 187 exactly divisible by 3? No. Is 187 divisible by 5? No. Is 187 divisible by 7? 7 2s are 14, 37. No. Is 187 divisible by 11? Yes. Which means 187 can be written as 11 into 11 ones are 11, 17. Now I can write 187 as 11 into 17 also. That means this number is not a prime number. Clear? So let's go with the third option. The third option says 110x plus 111x, which is going to give us how much, guys? 221x. Again, here the same logic. The value of x should be equal to 1. That means total number of employees are 221. Let's take the approximate square root is 15 here. 225 is 15 square. Again, the same numbers apply. Is it divisible by 2? No. Is it divisible by 3? No. Is it divisible by 5? No. 7? No. 11? No. Now 13. 13 ones are 13. We have 91. And 13 sevens are 91. That means this number can be written as 13 into 17. This number is divisible by 17. That's a 13. Right? Therefore, this number is not a prime number. Let's go to option D. 85x plus 98x. Now 98 plus 2 is 100. And so this becomes 183x. Again, 183 into 2 is greater than 300. So the value of x is equal to 1. So 183, I need not do anything because I know that 183 is 3 into 61. That means it is not a prime number. So finally, our answer becomes option E. Let's prove it first. So we have 97x plus 84x. So 97 plus 3 is 100. 100 plus 81 is 181x. Here also the value of x is equal to 1. That means total number of employees are 181. Again, square root of 181 is approximately 14. Now we check with 2, 3, 5, 7, 11, and 13. It is not divisible by 2, neither by 3, nor by 5. 7 twos are 14, 41, no. 11 ones are 11, 71, no. 13 ones are 13, 51, no. So therefore, this number is not divisible by any of these prime divisors. So therefore, this will definitely be a prime number. So I repeat once again, guys, for you to identify if a number is a prime number or not, your job is to take the approximate square root and divide by all the prime numbers less than the square root. If it is not divisible by any of the prime numbers, it is a prime number. If it is divisible by even one of those prime numbers, it will not be a prime number, right? Now let's look at a few more questions. Now, what is a composite number? A composite number C with some positive divisors besides 1 and itself, right? Which means a number which has greater than 2 factors is called a composite number. A composite number can be written as a product of two natural numbers that are both between 1 and itself. Suppose I talk about 6. So between 1 to 6, in how many ways can I write 6 as a product of two natural numbers? I can write 1 into 6. I can also write 2 into 3, which means since it is also in, 2 into 3, it is not a prime number. And if the number is not a prime number, it is definitely a composite number. So in short, if you ask me to simplify my positive integers, okay, positive integers can be classified as 1. Then we have prime numbers, and then we have composite numbers, because 1 is neither prime nor composite. Or positive integers can also be classified in the form of even numbers and odd numbers, right? So these are the two broad ways in which I can classify the positive integers, right? With the help of all the numbers that we have seen so far. Now let's look at a few questions here. What is the smallest prime divisor of 5 to the power 23 plus 7 to the power 17? Now 5 is an odd number. Odd to the power 23 will always be an odd number. 7 to the power 17. 7 is again an odd number. Odd to the power anything will always be an odd number. Now odd plus odd is equal to even, which means this number is an even number. If the number is an even number, the number is exactly divisible by 2. Right? And we know that 2 is the smallest prime number also that we have. And 2 is the only even prime number. And the question is asking you find the smallest prime divisor. So therefore, the smallest prime divisor here becomes clear, guys. Now let's look at the next question. Now I advise you to pause the question, do it on your own, and then get the answer. Sum of two prime numbers, let's say prime 1 plus prime 2, is equal to 1999. Now, it's time to define prime numbers. Prime numbers can be written as even number, that is 2, and rest all the prime numbers are odd numbers. All the prime numbers are odd numbers. Or prime numbers can be written in the form of 2, 3, 6k plus 1, and 6k minus 1. So these are two broad ways in which I can classify prime numbers, right? So now sum of two numbers is equal to an odd number. That means one of them has to be an odd number and the other number has to be an even number. Clear? Which means, and 2 is the only prime number we know. So 2 will definitely be considered even prime number we know. So 2 plus 1997 should give me 1999. Clear? And therefore, their product is going to be 2 into 1997 should be your required answer. That is 4000 minus 6, that is 3994 should be our required answer. Clear, guys? Now let's look at one more example here. Now, how many values of n satisfies such that n cube minus 1 is a prime number? Now, I just forgot to explain one more way here. Now, a prime number can also be written as 1 into a prime number. These are the three ways in which we can classify a prime number. Okay. Now, n cube minus 1 can be written as a cube minus b cube. Now, a cube minus b cube is in the form of a minus 1 into a square plus ab plus b square. Right? Now, n is a natural number. If this number has to be a prime number, then it should be in the form of 1 into the prime number only. Since n is a natural number, this value will be greater than 1. So our job is to get the value of n as, or this value should be 1, and this value has to satisfy the value of a prime number. So if I get n minus 1 is equal to 1, which means we get the value of n is equal to 2. If the value of n is equal to 2, this becomes 2 square, that is 4, 4 plus 2, that is 6, 6 plus 1, that is 7. So if I can observe that 1 into 7 is equal to 7 and 7 is a prime number. Right. So for how many values of n does this satisfy? There's only one value of n. That means the value of n is equal to 2 is the only value that satisfies. And then this number will be a prime number. Okay, so we are seeing in how many ways can we, apply the prime number concept. Now, p plus 2 and p plus 4 are prime numbers. How many values can p take? Now, this is an open-ended question. Okay. Now, let's try to understand. P is a prime number. P plus 2 is a prime number. And p plus 4 is also a prime number. Now, here, let me use p is equal to 2. So, p plus 2 becomes 4. P plus 4 becomes 6. They are not prime. Let's take 3. 3, 5, and 7. All the three of them are prime. So, one value of p is 3. Now, if I look at greater than 3, you need to understand that there will be infinite possible values greater than 3. Right. So, therefore, what will we use is we'll use this classification called 2, 3. Any prime number greater than 3 is in the form of 6k plus 1 or 6k minus 1. So, let's say this number is in the form of 6k plus 1, which is a prime number. So, this becomes 6k plus 3. Now, please understand 6k plus 3. If I take 6k plus 3, this can also be written in the form of 3 into 2k plus 1, which means this number is also a multiple of 3. If this number is a multiple of 3, this number will not be a prime number. Therefore, this is not a prime number. Similarly, I take 6k minus 1. Since p is a prime number, we can take 6k plus 1 and 6k minus 1. This value becomes 6k plus 1, which can be a prime number. But 6k minus 1 plus 4 will again give you 6k plus 3. If I again take 6k plus 3, this is again going to be a multiple of 3 because I'm writing this in the form of 3 into something. Right. So therefore, this case is also ruled out, which means the only possible value of p that we can apply is going to be 3, 5, and 7 from the whole lot of numbers that we have. Clear? Now let's move to the next question, guys. Now p is equal to a plus b, where a is the product of all the prime numbers less than 62. So what is the value of a? The value of a is equal to 2 into 3 into 5 into 7 into 11 into so on, so on, so on till 61. Now what is b? B is any number which is greater than equal to 2 and less than or equal to 61. Now, for how many values of b is p a prime number? Now, if I take the value of b is equal to 2, you see that 2 is available here also. So apart from 1 in itself, this number is also a multiple of 2. So this is not acceptable. If I take the value of b is equal to 3, 3 is again present here. which means this number is also a multiple of 3, which means it is not a prime number. If I take p is equal to 4, you have a 2 present here. So this number is in the form of 2k. 2k plus 4, but that means even number plus even number will be an even number. No other even number except 2 is a prime number. That means this is also not a prime number. Let's take the value of b is equal to 5. If I take b is equal to 5, I already have a multiple of 5. So this is in the form of 5k plus 5, which means this number becomes a multiple of 5. That means this number is not a prime number. So in that way, if you start assuming that any value of b that you take, you will have a multiple of b present here. If there's a multiple of b present here, which means they will not be a prime number because they have one extra factor called 1 and itself. Right? So therefore, to be very frank, for no value of b, will p be a prime number? And therefore, the answer for this question becomes 0 values. Clear? Let's look at one more question here. Again, a similar question, guys. Now, p is a prime number such that p is greater than 2016 factorial plus 1, which means p's first value becomes 2016 factorial plus 2. Then you have 2016 factorial plus 3, and so on, so on, so on. 2016 factorial plus 2015. These are the values of p. Now, what is a factorial? A factorial is product of all the natural numbers till the number itself. Now, how many of these are prime numbers? Obviously, none of these will be prime numbers because if I take 2 here, there is a 2 available here. That means this is a multiple of 2. Okay, that means it is not a prime number. So in 2016 factorial, you have 1 into 2 into 3 into 4, so on till 2016. So this will then be a multiple of 3. Then we will have multiple of 4 and so on, so on, so on. We will have multiple of 2015. So every number has its component available in 2016 factorial, which means the answer to this question also becomes 0. No value is possible. Clear, guys? Now let's look at one more question. Now it is an actual cat question. The number of positive integers n in the range of 12 to 40, such that 1 into 2 into 3 into 4, so on, so on, so on, till n minus 1 is not divisible by n. If it is not divisible by n, which means the numerator should not have any common factor with the denominator. Let's take an example, guys. Suppose I take 36 and I'm dividing it by 9. Now, what is 36? 36 is 2 into 18. That is again 2 into 9. That is 3 into 3. Now, what is 9? 9 is 3 into 3. So, there is a common factor available. There is a common factor available if all the factors of the denominator are present in the numerator. That means they are exactly divisible. Right. So for us to simplify this, the understanding is simple that no factor of n should be present in the numerator. And if no factor of n should be present in the numerator, which means that is only possible if n is a prime number. Right? Now n is a prime number, which means the values of n will be 13. Then we take 17, then we take 19, then we take 23, and then we take 29. And then we take 31 and then we take 37. For all these values of n, this will not be exactly divisible. Any other value we take, let's say we take 14. If n is equal to 14, 1 into 2 into 3, so on, so on, so on till 13 divided by 14. 14 can be written as 2 into 7. So this 2 gets cancelled. You have a 7, 7 also gets cancelled. Right, let's take 18 for example. So we have 1 into 2 into 3 into 4 into 5 into 6 till 17 and I'm dividing it by 18. Now 3 ones are 3 6 are 6 ones are 6 ones are, right? So we take any value, it will have its factor. If it's a composite number, its factors will be available in the numerator because what is a composite number, guys? A composite number is a number such that between 1 and C, it has 2 more factors. At least, okay? Which means if I'm taking n, if it's a composite number, between 1 and n minus 1, I will definitely have two such numbers. Two numbers a and b coming from here, which will always give me n. Right? If they're always giving me n, that means they're exactly divisible. Right? That means the number cannot be a composite number. So in short, the number will be a prime number. However, there's only one exception. Okay. Now that exception comes here. If the range of n is from 2 to 40, you need to understand for this question, the value of n is prime number. And the only exception is the number 4. Because if I take the number 4, 1 into 2 into 3, and I'm dividing by 4, they are not exactly divisible. So our answer in this case becomes prime number including 4. So you have 3, we will have 4, we'll have 5, we'll have 7, we'll have 11, 13, 17, 19, 23, 29. We'll have 31, and then we'll have 37. So we have 5 plus 5, 10, 10 plus 2 is 14. Therefore, 14 becomes your final answer. Okay, guys, so these are the different ways in which we have started looking at the prime numbers. We also saw in how many ways can we factorize a prime number or can we classify a prime number. We also saw in how many ways can I also write a composite number. Right, applying these logics, whenever the question is talking about prime number or composite number, we can apply these logics and get our required answers. Right. So thank you guys. All the best.